This is video 20 for College Algebra, and this is part 2 of graphing rational. So if you haven't watched part 1 is an introduction to horizontal and vertical asymptotes, and we briefly talk about holes. Today we're going to be talking in depth about what holes are and our slant asymptotes. So first of all, a hole is when the numerator and denominator have a common factor. It creates a hole. And that hole happens because we can cancel out those factors. So for our first example, I can cancel out my x plus 2's. My new function, after I've reduced it, is x minus 3 over x plus 4. Okay? And then x cannot equal negative 2, and that's when I put that factor equal to 0 and solve. All right, so that's where we would have a hole at. So here we can go ahead and fill this part in. We have a hole happening at x equals negative 2. Okay, and when we graph this, we actually just graph a hole in the graph. Now on your graphing calculator or Desmos, it will not show up looking like a hole, but looking at the table, it will show that it's undefined or does not exist. All right, so looking at, we can find our vertical asymptote. From there, we simply put our denominator equal to 0 and solve. So that would be x equals negative 4. Our horizontal asymptote, we're going to look at the coefficients of the degree, and our degree is 1, and so they're even, and so we've got a 1 and a 1 as our leading coefficients. So our horizontal asymptote is y equals 1. We can also state our domain. We know that our domain is going to be all real numbers, but x cannot equal negative 2 and negative 4, and that comes from our vertical asymptote and horizontal asymptote. For our y-intercept, we can find that by plugging in 0 for x, and so we've got y negative 3/4, and for our x-intercept, we plug 0 in for y, and we get our x-intercept as 3. So now we have all the key components for us to be able to graph this and make a fairly great sketch. So let's go ahead and graph our vertical and horizontal asymptotes. I'm going to do these in a different color this time. So we've got a horizontal asymptote at y equals 1, a vertical asymptote at negative 4, all right, we have an x-intercept at 3, a y-intercept at negative 3/4, and we know that somewhere along this line of negative 2, there's going to be a hole. So if I were to graph this, looks right about here at negative 2, I'm going to have a hole, and then I'm going to continue graphing. Now rational functions are always diagonal from each other, so I know that my other rational function is up in this quadrant. So that is my graph. All right, a slant asymptote. This occurs when a numerator has a greater degree than a denominator. And so when that happens, we're going to use synthetic division to find that slant asymptote. And so when the numerator is bigger, we really don't have, when the numerator is bigger than the denominator, we do not have a horizontal asymptote. So if you see that we have no horizontal asymptote, chances are we probably have a slant. So first of all, let's find all the things that we can. So my vertical asymptote, that's just going to be x equals -1. My horizontal asymptote, well, clearly I can see that the degree in the numerator is 2, the degree in the denominator is 1. So I have no horizontal asymptote, so I can find my slant asymptote. So again, we're going to divide using the synthetic division. So I've got -1 in my box, and don't forget placeholders. So I've got a 1, -1, and 0. We always drop down that first number. All right, and so after doing synthetic division, I've got x minus 2 plus 2 over x minus, or x plus 1. Okay, now our slant asymptote is just this first part. It's not going to include the remainder. So our slant is y equals x minus 2. All right, and then we can find our x and y intercepts, and those will be fairly simple to find. It's just 0 for both of them. All right, so let's graph this. We've got a vertical asymptote at x equals -1. And my slant asymptote is x minus 2. So I'm going to go down here at -2, and then I just go up 1 over 1. And then I can graph my function. I see that I've got my x and y intercepts at 0, 0. And we can graph our function here. And then our function will be down here at the bottom. All right, and that's how to graph with a slant asymptote.